Hello guys, let's talk today regarding multithreading in Java. My name is Inam Kadyrov. I'm working in EPAM as a software engineer. And today with Danila, we are talk about multithreading in Java. Let's begin. First of all, we need to find out the key definitions in concurrency, in multithreading, in multitasking. First of all, multitasking is multiple tasks running concurrently on a CPU. The operating system executes these tasks by switching between them very frequently. The unit of concurrency in this case is a process. For example, if you are using web browser and your IDE and in your browser you are listening music and in your IDE you are coding, that's multitasking. Multithreading, multiple parts of the same program running concurrently. In this case, we go step further and divide the same program into multiple parts, threads, and run those threads concurrently. And then we have process. A program in execution. It has its own address space, call stack, and link to any resources, such as open files. And what about thread? Thread, a part of running process. A thread refers to lightweight process. A thread will use the process memory, area, execution environment. Context switch time between threads is less because switch is done within the same process execution environment or memory area. We'll move on. In multithreading, we have concurrency and parallel execution. Concurrency, a condition that exists when at least two threads are making progress. A more generalized form of parallelism that can include time slicing as a form of virtual parallelism. Parallelism, a condition that arises when at least two threads are executing simultaneously. If you look to diagrams, in the first diagram, you can see one CPU in a single core system. Its threads tasks are doing their jobs concurrently in a slice of time of CPU. In the second diagram, we have two CPUs, and these two tasks are executing simultaneously. Well, multithreading in Java supported multithreading since every beginning. All standard libraries were developed with multithreading in mind. So threads in Java are controlled through thread class, and the multi-threaded program contains two or more parts that can run concurrently. Each part of these threads called thread. Each thread defines a separate path of execution. And in Java, we have two ways to create this kind of threads, extending from thread class or implementing runnable interface. Either of these approaches may be used, since multiple inheritance doesn't allow us to extend more than one class at a time. Implementing the runnable interface may help us in this situation. And also, there is multiple multithreading advantages, like better utilization of single CPU or multiple CPU or CPU cores, and better user experience with regards to responsiveness or fairness. Let's look at demo regarding thread creation. Here in this class, we have public class hello runnable, which implements runnable interface, and we are overriding run method. And in run method, we are doing some business logic. Here, in example, we are simply printing. And also we have hello thread class, which extends thread class. And also, while extending from thread class, we are overriding run method and doing in this method some business logic. In this case, we are simply printing it. Let's test it. Sorry. Here in line 12, we are creating new hello runnable thread and as a parameter to thread class. And we are calling start method. In line 16, we are creating hello thread class, and we are calling start method. As you can see in hello runnable, we have one more step, creating new thread class and passing this new hello runnable class as a parameter. This is the only difference in when creating threads by runnable interface. Also, we can create using lambda notation. As you can see here, we are using lambda notation, runnable object. In more detail, you can create a runnable object in this manner, simply creating new runnable and overriding run method. After creating threads, we can create a new thread with also with runnable object we created here and passing the thread name T1. And then we are called start. Also, we can create new thread and passing the runnable object created using lambda notation and passing it to as a parameter, and then call the start method. One of the common mistakes is using a run method. Run method is not the correct way to start the thread. So let's start the class main method and check it out how it works. As you can see here in logs, we can see how our demo thread creation is worked out. Here we are logging thread creation, and here we printed not using lambda, and also using lambda here. And you can see thread T1 as a name of the thread. Well, after creating threads, we also need to know about thread lifecycle and thread states. There are a couple of thread states: new, runnable, blocked, waiting, timed waiting, and terminated. If you look to the diagram, you can see new state. New state occurs when we create a class which implements runnable or extends thread class. Before starting start method, its state is new. After calling the start method, its state changes to runnable. Runnable means that either running or ready for execution, but it's waiting for resource allocation. After that, if everything okay and the task is done, it's terminated. It exists as the runnable state and changes to terminated. But in the process, we have non-runnable states. Timed waiting, waiting, blocked. Timed waiting. If we want to set the state to waiting, we can use sleep, wait, join, and other methods. And after time elapsed, its state changes to runnable. Waiting also, to change to waiting state, we can use wait, join methods, and after other thread notifies this thread using notify method or notify all method, it's changed the state to runnable. And blocked method, well, blocked method is waiting to acquire a monitor to lock, to enter or re-enter a synchronized method. Thread class has its own methods. For example, get name, get priority, and get state. Also, get name returns or sets thread name. Using set name, we can set thread name. Get priority returns the priority, sets priority. Set priority sets a new priority of this to this thread. Get state method returns the state of this thread. Start methods starts the thread by calling a run method. Run method is an entry point for a thread, for a task. Join method is used for waiting for another thread to finish. And Sleep temporarily suspends thread for a specified time. Interrupt method simply tries to interrupt this thread. Let's move on. Also, in thread class, we have isOlive and getState methods. And in this slide, we can see the relation of these methods. isOlive returns true if the thread has been started or may not yet be running, but has not yet completed its run method. GetState returns the exact state of the thread. As you can see from the diagram, we can use isOlive in relation to thread when it started, when we used started method. Main thread. When a Java program starts up, one thread begins running immediately. This is usually called the main thread of your program because it is the one that executed when your program begins. The main thread is important for two reasons. It is the thread from which other child threads will be spawned. And the second one, often it must be the last thread to finish execution because it performs various shutdown actions. Let's move on to code and check demo thread states and main thread. In this demo, we can see that we can get the current thread using the thread.currentThread, and we can lock this information. Also, we can set name of this thread, and we can lock also its. In this try catch, we are looping to get the information of how it's changed or not changed. Let's run it. As you can see, current thread main, and its priority main, and its thread group is main. And current thread state is runnable. After name changed thread my thread, its name priority is 5, and the thread group name is main, and it's looping. Let's move on to thread state demo. In this demo, thread state demo, we can firstly check out new, runnable, and terminated states. Here we are creating a runnable object and passing it to thread class as an argument, and then we are getting information about its state and name. And after that, we are starting it. Before starting, its state must be new. After starting, its state must be runnable. And we are making some sleep to wait the task must be finished. Yeah, let's start, run the demo and check it out. As you can see, the new state, runnable state, and terminated state. And also we can see blocked state. Here we have, first of all, we have demo thread B runnable object, which implements runnable interface. And there we have common resource, which is synchronized method, which is infinite loop. Yeah. And in the main method, we are creating two threads, T1, T2, and we are starting it. And thread, we are sleeping for 1,000 millis. We are logging and system exit because it's blocked. As you can see, T1 state is blocked. And T second thread is runnable because the T second, because T1 blocked and it's waiting. Right, let's talk about timed waiting state. Also, we are here demo thread, which implements runnable class interface. Sorry, and here we are making sleep to wait. And in the main method, we are creating demo thread, and we are creating thread and starting it and making sleep. The following sleep will give enough time for thread scheduler to start processing of thread 1. As you can see here from logs, the thread 0 state timed waiting. Let's move on. Let's talk about thread priority. Operation system thread scheduler uses threads priorities to determine which threads should get more CPU time. In general, threads with higher priority get more CPU time. Scheduling exampling on a single core system. As you can see in a diagram, thread 1 starts and then thread 2 starts and thread 1 continues. Java thread priority. Java threads may have priorities from minimal, maximal priorities. Currently, these constants are set to 1 and -1 respectively. The default priority is equal to normal priority, which is equal to 5. You can set priority with set priority method or get it with get priority method. Priority of main thread is to set to norm priority. Also, JVM supports scheduling algorithm called fixed priority preemptive scheduling. All Java threads have priority, and the JVM serves the one with the highest priority first. The thread scheduler might choose low priority threads for execution to avoid starvation errors. And in Java, we have context switching. Context switching decides according to thread's priority when to switch from one running thread to the next. And context switching uses two ways in deciding when switching between the threads. First of all, the first is thread can voluntarily relinquish control. It can use yielding method, sleeping method, or other. And the second one, thread can be preempted by a higher priority thread. Let's move on. Let's check out demo regarding thread priority. As you can see, here we have a static class clicker, which extends thread class, and here we have click or something like counter and volatile boolean running. And in run method, we are incrementing click. In the main method, we have two clicker objects, two threads, and we are setting high value and low priority. And we are setting minimal priority to low and high to max priority. And we are starting. And we are waiting. We are adding sleep. And we are calling stop click. Stop click changes the flag for running to false, to stop. And then we are joining to wait to complete the execution of these threads. And we are printing low priority thread click and high priority thread click. Let's start, run the demo and check it out. As you can see, we have a low priority thread and high priority thread. Let's move on. Daemon threads. Daemon threads in Java is a low priority thread that runs in the background to perform tasks such as garbage collection. Daemon thread in Java is also service provider thread that provides services to the user custom threads. Its life depends on the mercy of user threads. That is, when all the user threads die, JVM terminates this thread automatically. Well, in simple words, we can say that it provides services to user threads for background supporting tasks. It has no role in life other than to serve user threads, user custom threads. By default, the main thread is always non-daemon, but for all the remaining threads, daemon nature will be inherited from parent to child. That is, if the parent is daemon, the child is also daemon. If the parent is non-daemon, then the child is a non-daemon. And also we can use setDaemon and getDaemon methods in the process. Let's look the demo regarding daemon threads. We have daemon thread class, which extends thread, and here we have name. We are writing a super constructor, and here we are checking is it daemon or not, and here we are logging the information about this user thread. Well, in the main method, we are creating two daemon thread classes, T1 to T2 and T3, and setting daemon to T1 and starting it, and logging information about T1. And T3, we are setting daemon true. Let's start the demo and check it out. As you can see, daemon thread is T1, is daemon true, and the user thread 2, and daemon thread is T3, as you can see. Let's move on. Thread groups. Thread group creates a group of threads. Thread groups provides mechanism for collecting multiple threads into single object and manipulating those threads all at once, rather than individually. For example, you can start or suspend all the threads within a group with a single method call. Thread group can be nested. They form a tree where each thread group except a root one has a parent, as you can see in the diagram here. A thread is allowed to access information about its own thread group, but not access information about its thread group's parent thread group or any other thread group. Thread group class also has its own methods. For example, active count returns number of active threads in the group and its subgroups. Interrupts all threads in the group. GetParent returns a parent group on null if there are no parent. And also it has isDaemon method, as you can see, but it's deprecated in JDK 17. It returns whether the group is daemon or not. It's Boolean. And we can also have setDaemon, which also deprecated in JDK 17. And we have list method in ThreadGroup, which gives information, prints information about all threads in the group. Also, we have destroy method, which deprecated in JDK 17. And this method, as you can see, destroys a group and its subgroups. They must have no threads. If they have threads, it will show illegal thread state exception. Also, we can have a method regarding priority setting max priority and getting max priority. Let's move on. Well, a thread group may be a daemon group. Such thread groups is automatically destroyed when it becomes empty. This flag doesn't have any relation to thread is daemon method flag. Well, regarding the max priority in thread groups. If a thread with a high priority is added to a group with lower priority, its priority will become equal to thread's group. In another case, if a thread with a low priority is added to a group with higher priority, its priority will not change. Let's move on to demo and check it out in the code. Here we have new thread class extended from thread, and we are here we have constructor. And in the run method, we are simply adding sleep to make it more visible and logging information if they catch exceptions. In the main method, you can see here we created thread group using ThreadGroup class with new operator and passing a name for this thread group. Also, we created second child thread group by passing as a parent the first thread group and giving name child. Then we are creating threads with a new thread and giving the name 1, 2 and starting it. Also here we are getting active count method to get active count threads and getting get parent and logging its information. Here we are getting parents of child group, and here we are getting information about child thread group threads and parent thread group threads, and after we are adding sleep and getting interrupt. Let's run the demo and check out. Here you can see in the log starting 1, starting 2, number of active threads. As long as we have 2, it's equal to. Regarding information about the parent is name main. That means the first here, the parent of this thread group is main, and maximum priority is 10. And then the child group's parent is thread group and its name parent thread group, as we gave this kind of name, and maximum priority is 10. And also you can see exception secure after calling interrupt method. Well, you can ask where is the results of this method's list. Here you can see thread group name child max. As long as it doesn't have any threads, doesn't have any information here. Here we have thread group name parent thread group, and here we have 2 threads, 1, 2, and we are getting information about them. Let's move on. Well, exception handling. Uncode exception handling in Java, while exception handling in threads, we can use uncode exception handler. It's a specific interface provided by Java to handle exceptions in thread run method. Parent threads don't handle uncaught exceptions from child threads. Unhandled exceptions get lost. And to handle exceptions, as I said, you can use uncode exception handler interface by using, as you can see here, you can set using thread set default uncode exception handler, you can set global default exception handler. And by using to the current thread, you can set default uncode exception handler, and you can set for this specific thread, you can set exception handler. And also, you can also extend the thread group and override uncode exception that is called when child thread does not handle exception. Well, JVM will throw an exception named illegal thread state exception whenever we attempt to call a method that a thread cannot handle in a given state. For example, thread that is in a sleeping state cannot deal with the resume method because sleeping cannot accept instructions. The same is true for the suspend method when it is used on a blocked thread. When we call a thread method that may throw an exception, we will have to use an appropriate exception handler to catch it. Let's move on. Thread interruption. Well, in Java, one thread cannot stop the other thread. A thread can only request the other thread to stop. this request is made in the form of interruption. That means thread interruption. Calling the interrupt method on an instance of a thread sets the interrupt state as a true on an instant, as you can see here. Interrupted method to check if the thread is already interrupted, but it clears the interrupted status. That means it changes state. Is interrupted to check if is used to check if the thread is already interrupted and does not clear its status. Move on. Let's check exception handling demo. Here you can see we have simple thread which extends thread, and in the run method we are throwing a runtime exception with some kind of information, the thread name and the runtime exception. Let's in the main method you can see creating simple thread, starting and joining it. And also we are creating simple thread. And we are setting default global exception handler using thread and starting it. And then we are creating one more simple thread and setting the specific exception handler to the current simple thread 2. Let's run the demo and check it out. As you can see, we got exceptions regarding the thread 0. It's a runtime. The thread 2 won't finish it as lambda. As you can see, lambda uncaught exception. And the thread 2 got exception, got simple message. And thread 2, it's runtime exception. Let's move on. Synchronization. Well, one of the most common problems in multi-threaded application is a problem of race condition. Well, in a multi-threaded environment, when 2 or more threads attempt to update immutable shared data at the same time, occurs race condition. Java offers a mechanism to avoid a race condition by synchronizing thread access to shared data. A piece of synchronization is required when several threads access the same area in memory to guarantee that only one thread may access at a time. Lack of synchronization may lead to unexpected results, and a key concept for synchronization is a monitor. Each Java object has an associated monitor. Monitors are also called mutexes. An overall monitor is a synchronization mechanism that allows threads to have a mutual exclusion. That means only one thread can execute the method at a certain point of time using locks, and cooperation, the ability to make the threads wait for certain conditions to meet using wait sets. Well, in overall, a piece of logic marked synchronized becomes a synchronized block, allowing only one thread to execute at a given time. When we can use synchronized keyword. Synchronized keyword can be used for synchronizing access to code. It can be used in 2 ways: synchronized method and synchronized block. When we use synchronized block, Java internally uses a monitor, also known as a monitor lock, to provide synchronization. These monitors are bound to an object, therefore all synchronized blocks of the same object can have only one thread executing them at the same time. If 2 threads try to enter a monitor at the same time, only one succeeds. Another sleeps until the first exits synchronized code and releases the monitor. When a thread waits for a busy monitor, its state changes to block. Let's look at the synchronization demo and check it out. Here we have counter class, which extends thread, and the counter class has class attribute count, and default value is 0. In override method, as you can see, we have synchronized keyword, and we have here a loop for loop, and here max is 1 million. And inside the loop, we are incrementing count. In the main method, we are creating instance of counter class and defining two different threads using this counter class, the first and second. And we are starting these threads and joining. That means we will wait both threads to complete execution and printing the result. Well, the result must be 2 million because we have maximum 1 million. We have two threads, and to sum up, it will be 2 million. Let's try to run. As you can see, the result is 2 million. Well, you can see the difference if we remove synchronized keyword. Let's rerun. As you can see, the result is unpredictable. That means these two threads uses this method, run method, and incrementing it improperly. Let's move on. Well, Java includes an elegant inter-thread communication. Inter-thread communication mechanism through wait, notify all methods. All these methods can be called only from the synchronized context. The rules for using these methods are actually quite simple. Wait causes the current thread to wait until is okayed, typically by being notified or interrupted. It means wait tells the calling thread to give up the monitor and go to sleep until some other thread enters the same monitor and calls notify or notify all. Notify wakes up a single thread that is waiting on this object's monitor. That means wakes up a thread that called to wait on the same object. Notify all wakes up all the threads that waiting on this object monitor. That means wakes up all those threads that called wait on the same object. One of the threads will be granted access. Also, wait normally waits until notify or notify all. Notify is called. Yeah, there is possibility that in very rare cases the waiting thread could be awakened due to spurious wake up. In this case, a waiting thread resumes without notify or notify all having been called. Because of this remote possibility, Java API documentation recommends that calls to wait should take place within a loop that checks a condition on which the thread is waiting. Let's move on. Let's move on to a demo regarding inter-thread communication. Here to show you inter-thread communication, I'll try to solve producer-consumer problem using wait and notify. Here we have producer thread, which produces string and adds to queue. Here we have queue static, it's array list, and we are in producer, we are pushing their string. We are adding string there and notifying all. In consumer, also here we have synchronized. We are checking, logging waiting. We are waiting. If it's notified, thread will be notified. And after that, string will be removed and log information about the removing will be printed. Here we have sleep in the producer and consumer to show more precisely. Let's try to run. And in main method, we are creating producer thread and consumer thread, starting and joining them to wait the execution. As you can see, the producer thread pushing, consumer thread removed, consumer thread waiting, and so on. And it will run until 10 because we have maximum value until 10. Let's move on. Well, deadlock. While multi-threading helps in improving an application performance, but it also comes with some problems. One of them is deadlock. There are also another errors like starvation, life lock, but deadlock is more it's simple case, yeah. Deadlock is a situation when two threads are waiting for each other and waiting never ends. Here, both threads can complete their tasks. Consequently, an application may fail and the deadlocked threads cannot progress. That means it occurs when two threads have cycle dependency in pair of synchronized objects. In other words, thread 1 owns monitor 1 and the waits for monitor 2. In contrast, the thread 2 owns monitor 2 owns monitor and waits for monitor 1. Well, deadlock may include more than two threads, but such cases are uncommon. One way of avoiding deadlocks is to enter monitors of objects in the same order. We can detect deadlocks using tools like JSTAG and so on. Let's move on to demo and check it out. Oh, sorry. Here we have thread A, which extends thread, sleeps, printers. It's synchronized. As you can see, synchronized and passed object A. And here we are inside of synchronized. We have synchronized method object B, block, and we are printing. Here we have deadlock demo, and we have final objects, object A, object B. And here we are creating two threads, thread A, thread B, starting and joining to wait the execution. Let's start demo to find out. As you can see, here is deadlocked, and how to detect deadlocks. You can use, just a second. Right. Well, you can use commands GPS, and you can find the PID using this command. And you can see here it's PID for Gradle, and here we have PID for deadlock demo. And using GSTag command and passing PID, it's here 72875. Yeah. As you can see, Java stack information for threads listable found one deadlock and the information regarding these deadlocks. One, suspending and resuming threads. Well, you can pause an execution of a thread with suspend method, later it can be continued with resume call, but these methods are deprecated because they can easily lead to deadlocks in application. These methods should be used regularly with a great caution. Volatile. Well, volatile is yet another way of making class thread safe. Suppose that two threads are working on a shared object. If two threads run on a different processors, each thread may have own local copy of shared object or shared variable. If one thread modifies its value, the change might not reflect in the original one in the main memory instantly. And now the other thread is aware of modified value, which leads to data inconsistency. In such cases, we can use volatile keyword, and undesired effect is allowed by Java memory model if usual variable is shared between multiple threads and one of them makes changes to it. Others are not guaranteed to see that change on subsequent reads. The following, as you can see in the slide, following code may run forever if run flag is updated to false from another thread. And to avoid such problems, shared variables should be made volatile. Volatile variables are not cached in processors. They are saved in the main memory. Reads are directed to main memory and writes immediately flashed there too. Only variables that are shared between threads may be made volatile. So you can't make a local variable volatile. Let's move on to demo regarding volatile. As you remember clicker, we have a clicker and which extends thread class. We have a click count or something, and we have volatile boolean running flag. And in run method, we are overriding click. We are incrementing click stop. And stop click, we are changing the flag from running from true to false down. Well, in the main method, we are creating clicker object, runnable object. We are creating, starting it and making sleep it, and we are stop the click. And in the for loop, we are printing the click count. Yeah. Let's try to run up. As you can see, the all values the same. Why is that? Because we use it volatile while changing running flag. If we remove it, you can see the difference. As you can see, they are all different. They are all different. That means click is different all the time, even after stop clicking in our for loop, in our clicker object. Yeah. Can stop it. To volatile. Well, I think we can finish here as long as it is the first part of multithreading in Java, and we can continue in the second part of this multithreading in Java and from the parallel streams.
I forgot to unmute myself. Yeah, thanks a lot for this presentation. I think it was really cool. As far as monitoring tools like GStack are concerned, we will have a separate light talk on them. We will see some visual tools and GStack also. Yeah, we now have, as I see, 4 questions in the chat. If you have more, please ask them now. The first one, is it better to use the executors than the bare thread and runnable?
Sorry, I didn't catch the question. Using executors, you mean the... Yeah, using executors is really good. When using executors, here didn't know anything about the threads. It uses thread pool. It's not creating threads every time when the request comes. Using executors is very helpful, and it saves resources.
Yeah, I would add that you should use executors when you can. I think we will cover them in the next light talk, but there are some cases when you can't use executors, and well, they always rely on these threads and runnables, so it's good to know well, the base of the executors. Okay, the next question is why was the count of low priority threads almost the same as the count of high priority threads?
Well, it depends on operation system, and also it depends on the number of CPU cores. That's why it's really the same, because I have a MacBook laptop, MacBook Pro, and it has too many cores. That's why it's the same as high and low. To find out more difference, we can use more. We can create more threads and to check it out.
Yeah,
Thank you.
You have to have more threads than your computer supports to start thread switching, and so then you will see that high priority is executed more often. Okay, the third question is how to kill the threads correctly.
Well, there is a couple of ways correctly killing. Well, in overall, we can't kill the threads. We can call the interrupt, and using interrupt, it means that we change the state, and when it can GVM responsible to kill the threads.
Yeah, and when you call the interrupt method, it just sets the interrupted flag on the thread. So the thread itself has to check if it was interrupted, and if it was, it should finish the execution. As far as I remember, there used to be a method to kill a thread. I think it was stop, but it was removed from Java 8 probably because it was too dangerous to use. Okay, and the last question so far, guys, you still have some time to ask more. Do you often use thread groups in your daily work?
Actually, no. Actually, no. Thread groups we are not using. We are using almost executors, yeah, most of the time. We also using not the multithreading, but reactive programming in our daily jobs, yeah. Well, it depends on the project and depends on the business logic. For example, in finance, you should use multi-threading because in a bank there is multiple transactions between the accounts, and you need to make the system work perfectly. And it's really needs multi-threading in such kind of applications.
Okay, thanks a lot. I don't see any more questions. I will wait for a few more seconds. Yeah, no questions, so thanks a lot again for this presentation. Guys, see you next week.
Thank you, guys. Thank you for your attention.